Hey, so you can draw up the diagram all by yourself. The diagram we see here, it only looks complicated, but if you actually study it, that's why you are supposed to study. Ayokis, learn, pay attention to it and understand it. You can see the focal length being shown as F, and you can see the flying height also shown. Ayoki. So flying height is from a datum to the exposure station. It should be from a datum. A datum is a reference surface. An example is a mean sea level, but you can create your own datum on any project, an engineering project. Are you okay? If you are asked to create a datum, you can give it a height of 100 or something and then work from there. If you've actually worked on a construction site before, you know what I'm talking about. Okay. So an assumed datum, that's what we want to call it. Doesn't matter what you call it, but there's always a reference, an imaginary surface from which all measurements are done. Are you okay? All right. So the flying height is shown up there. You can also see your focal length up here, from here to here. And then all you do is to sketch it up nicely. Okay. You have to understand how to draw like this. Are you okay? If I were to draw or put a building on this, I'm intentionally being very practical because I know most of you are very practical. If this were a building, okay, then you can just put it there and then it will be captured in the photograph. Okay. Let's pick one corner of the building that gets picked up. Okay, so this corner can be, you draw a straight line that goes to, okay, and so it means the building will be appearing somewhere up there. Okay, all right, I want you to appreciate these drawings. So I'm spending time on it. Well, as you see them, let's know exactly what they are about. Let's move on and look at the formula for calculating the ground coordinate. But these coordinate systems are not the ground coordinate that you know of from SM survey and mapping, as you know already. These coordinates are for the photographic coordinates. They are not real ground coordinates. All right, so the proof of it is to use similar triangles. Are you okay? For similar triangles, that's all the job in photogrammetry. In fact, most of the formulas are from similar triangles. Okay, so take your time and look at it. We can prove that the ground coordinate has a relationship with the photo coordinates. So if you look at this formula here, you can see that the smaller xa is a photo coordinate. HA is the height or elevation of a point A, which you can have millions, thousands of them, an infinite number of them. H is the flying height. F is the property of the lens, the focal length of the lens. Okay, and then you get your ground coordinate. Okay, XA. So you can do it for YA. Okay, as well. But obviously, we don't do for ZA on purpose. Z is always going to be a challenge, but we just take it that this is a simple, formula that we can actually always use. All right. So given a set of values, we should be able to calculate the ground coordinate. Let's look at this example. Okay. So in this example, a vertical photo was taken with a 152.4 millimeter focal length camera at a flying height of 1,385 meters above the datum. Okay, so flying height has been given to you above a certain datum. We don't even mention the datum. Focal length, I've told you, David, if you can hear me, that focal length throughout the course is always going to be like 152.4 millimeters. So even if it's not provided, always kind of assume. The measured photo coordinates and ground elevations are given in the following table. So measured photo coordinates and ground elevation. So we have X, okay, XY photo coordinates, and we have the elevation of the point on the ground. Okay. So I think this is really a done deal. When you look at the formula again, H minus HA over F times XA. Okay. Can we chew this and put it in our head? You can memorize this. Very simple, isn't it? You have the height on top and then we have this downward. So a little bit of chewing is important. You know what chewing is, don't you? So we're gonna just do XA is equal to H minus HA. The flying height is so much, it's like 3,000. So you can imagine if you swap this, you'll be getting a negative value, and it's gonna be so wrong. Are you okay?
Yes. There's no negative in survey.
F, exactly. You don't have any negative in survey. Yes. I don't know why we don't have a negative, but we should have, isn't it?
Because of the because of where we started our coordinate system from.
Okay, so it's not rocket science. Okay, don't put that in your head. It's okay. As you move forward in life, remember that it can be wrong. Always put it in your head.
Yes,
okay?
yes.
Mm.
Yes, sir.
Okay, so this formula is very easy, isn't it? Okay, so flying height is what? This 1385 meters is okay. 1385 meters. So your units, always check your units. And if you take, determine the horizontal length. So horizontal length, how do you work out the horizontal length? Okay, let me ask the class before we even do this one. What's the horizontal length of a line? How do you determine the horizontal length? Between a line is made up of 2 points, the beginning and then the end point, isn't it? How do you work out the length? Who knows how you do that? So that we know, we're talking about ground coordinates and now we have the horizontal length. What do you think? What do you think is a length? Horizontal length of a line. How do you determine it? David, all of a sudden you've gone quiet. You're the one that was laughing just now. Where are you? So the length of a line, are you okay?
Yes, sir.
You put it in your mind. It's very, very easy to do. All you do is just work out. If you have AB, okay. So the length of line AB, LAB, equal to, you simply find, you use SOHCAHTOA. Is that okay? Oh, this one is not Pythagoras theorem, not SOHCAHTOA. I just want to mention the phrase. Okay, you just do the change in the eastings and northerns. Okay, so
yes,
delta N, delta E, delta eastings, delta northerns, square it, exactly, plus delta easting squared. Find the square root of that. Okay. Please don't repeat after me. Okay, don't do that. I don't like that. Okay, so LAB is equal to another way of looking at it, because that's why I asked you. When I ask you, I want you to say something. All right. When you don't say anything and I start talking, don't be repeating. Okay, so delta northern is like saying changing the y coordinates. Is that okay? So that will be like delta y squared delta x squared. Okay, and that's because according to Pythagoras theorem, the square of the adjacent and opposite is equal to the square of the hypotenuse. I mean, we are not doing JSS here. Are you okay? All right, so square root of how do you get a change, the distance from the length? Okay, delta and delta x. How do you get that? Okay, Dave, now you can talk. How do you get delta n or delta y? And don't tell me you don't know. When I start saying, start repeating. Yes, what's delta n? How do you get it, Dave?
It is after we square root.
No.
Both.
Dave, hold it. Take it easy. How do you get your delta and your change in northings or change in y? How do you get that? Listen the question well and then you answer it. How do you get it?
Please, it is after.
No, it's not after. How do you get it? No. How do you prepare banku? You take the condo and you add some water. Is that not so?
Yes, sir.
How do you get the change in y? The change in n? How do you get it?
So please, we use the triangle.
No.
That's our
no.
adjacent.
Dave, hold it. That's not the way you do it. Okay?
Okay.
You want this, Dave. Watch me. I hope you're watching watch the board.
Yeah.
You want this distance. Is that not so?
Yes.
Okay. How do you get it? That's the question. So you should just take it easy. It's not about the triangle, it's about that part. How do you get that? Okay, so you take the yes, how do you do it? Who knows how you do that?
Yeah, so let's say you want the change in the delta n. It's because the northing of B minus northing of A.
Thank you, exactly. So northing of B, northing of A. Are you okay? The difference, are you okay, will now give you this, which means that northing of A is from here to here. The northern of B is from here to here. So it's like, please, whoever is making noise, mute your mic, okay? Before I remove you, I can teach one student. So if you're only 3, don't think I'm not, mute your mic. Okay, so, but you can unmute it to say something, but don't let someone be making, shouting behind you, like my niece wants to do behind me right now. Do you want to do that? Okay, she said yes, she wants to shout, but she's not allowed to. Okay, so it's like we're cutting this part of it, the NA, from the bigger chunk, which is actually MB, which is from here to here. Are you okay? So then we get the remainder, which is actually from here to here, which is actually this one, which we are looking for. Okay. All right. So we can say LAB is like doing YB minus YA squared plus XB minus, you can actually turn it around, you still get the same thing. Okay, squared. Okay, meanwhile the topic is ground coordinates, which means that that's the reason we've been asked to calculate the length of a line. Why? Because the length of a line makes use of the coordinates, the end point coordinates. Are you okay? The end point coordinates. All right, so that is why the question is asking us to do that. So given this, okay, for point A with this ground coordinate, to get the ground coordinate for XA, we need to make use of minus 52.35. Okay, so formula again, XA equal to flying height all over XA. Okay, and so we know smaller XA to be minus 52.35 millimeters. The flying height itself is 1358 meters. 1385, sorry, 85 meters. And the ground elevation for point A is 204 meters. Someone is wondering, how am I getting that? Because I can see it from here. You can see it, 204 meters. Okay, this value. Okay.
So always the flying height is the elevation, right?
Your question is not clear. Rephrase your question. Say it again.
I'm saying that the capital H is always on the table is the elevation.
No. There's no capital H on the table. So that's what I'm saying. Your question is not clear. The capital H.
Okay, the formula.
The formula is capital H represents flying height. Is that not so?
Flying height, that's it.
Okay, and then H subscript capital A is the height, the elevation of a point A. In other words, we can have H capital B, H capital C, H capital Z. So the points are point B, point C, point Z. Are you following what I'm saying?
Yeah, I know.
You can have a lot of points like that. Okay, so H subscript I up to H subscript capital N, where I, are you okay, represent a letter, are you okay, or a label for the points of interest. Okay.
Okay.
All right. And these points can be a lot. They are infinite on the photograph, but we are only interested in probably the top of a church building, the height of the ridge of a church building, or the top of a hill. Are you with me? Why? Because there's something going on there. So that's the formula is for a particular point. It only calculates the coordinate for a particular point using the height of that point on the ground. Okay. All right. So going back to the formula, we're looking for the height. In the table, the height of point A on the ground, capital A is what? H capital A is what?
204.
204 meters. Okay, so 204 meters. 204 meters. So we can subtract this because the two are in the same unit. And then 152.4 millimeters. Okay. And then we can multiply this by. What is the coordinate for point X? Minus 52.
This one is given in the question.
0.35. 35 millimeters. So we can cancel millimeters. Okay. And then we simply subtract flying height. What do we get at the top?
We get 1181.
Okay, 1181 meters. So our answer is going to be in meters. 181 times minus 52.35. So you see the answer will be negative. It will be negative. Okay, so then ground coordinate doesn't have to be the survey type of coordinates, like I was saying to Dave. Are you okay? Okay.
Yes.
All right. So there we go. So what do you get? In fact, this one, I think my niece can do it. She's right here with me. She can do this calculation. Should we call her to come and do it? Okay, anybody can do this. It's okay. You get the answer in negative and then in meters. Is that okay? Very, very easy stuff that we have to go through. So I'll just show you, the solution.
So it's negative.
Yes, you get negative. And then we can do it for the other ones. I don't think I'll let you, we'll not waste time on this. We assume that this is something that everybody can do, and we understand the formula and how we ended up with the set of values that we got. Are you with me? Now, when we're done, we also know the formula for distance using coordinates, as we proved. Did we even prove it? I mean, as we shown on the board, as was shown on the board. So LAB is subtracting and squaring, okay, the differences in coordinates, or horizontal coordinates, and we just get a distance, a certain distance. Simple as that. I don't think much is really required. Okay, any question on coordinates? We're done. We are moving. We are changing topic. Any question? Let me have it, please. Any questions so far? Any
So
questions?
maybe next week.
Any question on coordinate systems?
So maybe next week.
Question.
I'm asking for questions, so don't suggest when I should be asking you. When you should be asking.
Like I'm saying, like after we've gone
said, do you have a question? Let's not argue about it. You don't have a question, just say you don't have a question. Yes. Do you have a question?
Sir, yes. Assuming I have a photograph.
Yes.
And taken from, and I want to find necessarily the max on it to be able to measure and get the coordinates.
How would you go about it? So that's your assignment. That reminds me of an assignment that you'll be doing. I'll be sending you some photographs, all right? And I expect you to scale or measure the coordinates, the photo coordinates from the photograph. Is that okay? Now,
so that's why.
Yes, but last week, David, I think we explained, and I think this morning, okay, I haven't talked much about it, but last week we talked about the coordinate system, the photo coordinate system, and the fiducial coordinate system, and how the two relate. Do you remember? David, do you still remember what we talked about it? David?
So I don't remember.
You don't remember?
Yes, sir.
Wow. Okay, David, I think you have a memory problem. And I have to, sorry about that. Because we talked about it, we drew it. I drew the fiducial coordinate system with an origin, and then we drew the photo coordinate system as well. And I'm surprised today you are saying this. Yeah. Why are you doing that, Dave? I don't know. Were you sleeping last week, or what was happening? Eh?
So no, I was just.
I have a lot to talk about too.
Yes, sir.
I don't think that we're gonna stay at one place. Okay, but let me recap for the rest. Those who didn't come without excuse, don't wait till you go and have a trail and you'll be following me around and be calling me at evening time and be telling me about stories. Is that okay? Please.
Yes, sir.
I don't like that kind of lifestyle. Okay, so if you have a point A, this point could represent the corner or the intersection of, say, some kind of feature on the ground. Are you okay?
Yes, sir.
Let me do it again. Let's assume I have a T junction. I'm just making a sketch. All right, and then there's a point of interest, the one that I've marked. Oops. Okay, so how do I get a coordinates from that? So this is a photograph. This rectangle with black border, black outline, is actually what a photograph. Let's assume that. And on that photograph, there's a feature on it. All right. Now, let's go over it again. In photogrammetry, left to right represent the direction of light. Okay, so this is the direction of light. And it's also the x-axis. Okay. All right. 90 degrees to sit down and just be calm. All right. So I'm not talking to class. I'm talking to my niece right here, lovely niece, but she want to hurt herself. Anyway, so now your y-axis is orthogonal to the x-axis. To get the s-coordinate of a point like this, you simply measure the s-coordinate is along the x-axis like this. Okay, so this is it. That's how you get your x. If the point is called B or P, you call it XP, smaller letter P. That's a distance. Then your y is this way. You measure along the y to the point. So you can see that there are some dots that's tracing to the point. Are you okay? Okay. Otherwise, what you can do is that you can just, so you take a ruler, make sure it's parallel to the x-axis, measure to it. Okay. Because a photograph is not that big. For you to use a ruler to even, or you can use a set square, and you can just scale it, get the coordinates. So the center is the origin for the photographic coordinate system. Are you okay? The photo coordinate system, the center of the intersection of x-y coordinates represents what? The origin. Okay, so it's 0, 0. So we can now measure from the center going to the right is positive, center going upwards is positive, going down is negative, going to the left is negative, which is that we can get a coordinate here for point C, and then the coordinate will be negative. Are you okay? Because it will be, if you get 10 millimeters here, that's minus 10. And you have to bring the minus 15. That means 15 millimeters. Are you okay? All right. So that is the way it goes. The standard format for most photos for this course will be 230 millimeters by 230 millimeters. Okay. Then again, we have 10 minutes to finish this session. When it's ended, we join again with the same link. Is that okay? All right. So, David, you asked a question. Is it clear to you how you do that? This is the second time I'm talking about this.
Yes, it's clear.
Great.
So you send us images to measure.
Say that again.
I said, so the assignment is you give us images to measure.
I'll give you an image and I'll expect you to, I'll give you the instruction exactly what to do. Are you okay?
Then give the coordinates.
Yeah, but then you will need the coordinates. You need the photo coordinates.
Yeah.
So I'll send it, once I send the images, I'll send the instructions as well to you.
All right.
In fact, the idea is this: I'll let you do some calculations for ground coordinates. You probably do something on parallax. It will be up to you. I'll leave it to the student to choose about 3 things, calculations to do on the photograph. Is that okay? Very simple assignment, isn't it?
Yes.
Just do it,
Yes,
and I'll give you some marks for that. Remember that I'm scoring these things. So it's not like for a joke. I'm giving you marks for it, up to 30 marks, really. And then your attendance too will be factored into it. If you don't show up, you won't get you get maybe 15 out of 30. Doesn't matter what you do. Okay. All right. So that's that. So that's how you get your photo coordinates. Okay. Any more questions on how you get your photo coordinates? If it's not provided to you in a question, like the way we done in this question, the coordinates were given. So here, you just take the point A, X, and then you have to determine yourself. Okay, here, the trick is this. You have to detect, let me try and draw. You should know that this and that are on the same line. These values relate to point A. Are you okay? Therefore, this one then becomes X, smaller letter A. So you have to detect that, okay, minus 52, x subscript a is equal to minus 52.3. Otherwise, when you put the formula down, you wouldn't know which one to put where. Do you understand?
Yes, sir.
Okay. Someone says he doesn't understand over here. Y subscript A, you have to write it yourself and say that Y subscript A is equal to minus 48.27. Now 204M is actually smaller h subscript capital A. What it means is that I can confuse you by simply putting here, instead of AB, I'll put CD. And then when you look in the formula, it wouldn't make sense. That's why your understanding of what we are doing is the most important thing. It's not about you chewing the formula. The formula does make use of A, the letter A, but you can replace the letter A with anything. If I put here point P1, then you read that X subscript P1, Y subscript P1, H, then capital P1, that kind of thing, you know. So you should do this with understanding. Otherwise, what we do in the exam is that we don't just give you the question, we intentionally tweak it around so that you see if you really kind of understood it or you just chewed it. Let's assume you're actually copying an exam and you open this page and you're looking at it. And then I've actually put V and W here. Now you'll be thinking, is V A, is W B? Are you with me? It's up to you to now map it and relate what's in your notes to what you've been given in the exam. Okay, any questions on coordinates? If you don't have any more, we are moving on. We have a lot to cover, so I don't think there's time to waste on this. You can all do this calculation and get it right. Okay, let's talk about relief displacement. So what is relief? We have 5 minutes, then we'll change topic. Do you know what relief is? What is relief? Okay, all right, so my niece has answered the question here. So you guys, you have a challenge. My niece has answered the question of what the relief is. So let me hear you. Oh, you people don't want to. I'm not trying to embarrass you, but I think we need to learn. Are you okay? All right.
Relief.
Yes.
As in the English word.
You said?
As in the English word relief, or in relation to the course?
In relation to the course. Okay. So you couldn't answer it. So you need to send me, all of you, send me 5 CDs to give to my niece over here. Is okay? He said, can you say it again? You see what she said, that makes the whole thing interesting. He said we have high relief and we have low relief. Are you okay? High relief. I'm not trying to embarrass you. We are learning. Learning is like that. If you're not humble, you can't. The things you even think you know already, they may not be perfect. So let's all learn every day. I'm not embarrassing anybody. High or low relief. What it really means is that, see, relief is about height and elevation. Are you okay? So when you have a mountain, okay, then that's relief. So the representation of something high in terms of height or something that is low, that is what we call relief. What does it mean? It means you can actually have an area with low relief. Okay, you can have an area with what? Low relief. Okay. So when you look at this diagram, concentrate on the line that's below, belief, that's below. Now look at it. You see the relief right there. Here's a land. This is Kwao Mountains or Equape Mountains. Are you okay? Imagine. And we are looking through a section. We're cutting through it. Now you see that the whole idea of relief is that the ground is undulating and it rises in terms of elevation at some point. All right. That's relief. literally representation of these forms, okay, or something that has a height on a photograph, it creates an error. Okay, it creates an error, and we want to look at what it is. It's like an error. We can also call it displacement, because in this particular lecture, we want to bring your attention to the ability to calculate the height of an object. Are you okay? Using this equation, an equation. Are you okay? All right. So the relief of point A, or the height of point A, is actually h subscript A. Okay. And it's usually above datum. From here to here is what is making us talk about relief. Are you okay? So an area without relief is an area in which the ground is like this, almost like flat. Okay, then there will be no relief. In other words, the datum can be assumed to flash with the surface, the ground. Are you okay? The surface of the ground surface. All right, then there's not much relief. Also, let's not forget that a building can also be considered to be relief, because it also has a height. This can be a 50 story building. Are you okay? Going through that is also relief. So on the photograph, these things tend to shift. Okay, so join again. The Zoom session has ended. Please, let's join again. All right, let's join again and continue from there.